thinking about it. Okay. Today's lesson is area, squares, and square roots, and it is in your textbook, so please make sure you have it nearby. We call raising x, whoa, we call raising x to the power of 2 x squared, or we can write it x squared, because you can model a quantity that is squared by the area of a square. Right? So we modeled integers, positive and negative ones, with algebra tiles. We can model squaring with squares. That's actually why it's called x squared. Think about why x cubed would be called x cubed. Why is x to the third power x cubed and when x to the second power is x squared? And here's some examples. If the side length is 4, then the area is 16, which is 4 squared. If the side length is 6, then the area is 36, which is 6 squared. So in your book on page 34, there's a table here for you to fill out. They are thinking, hey, you're going to create a booth for the gym, and you need to know how much of the gym floor it's going to take up. So if the side length of the booth is 3, you could do 3 times 3 to figure out that that booth would be sitting on 9 square feet of surface area. So this is surface. All area is surface. Area is literally how many squares it takes to completely cover something. And it's always squares. Even if I'm covering a circle, I'm covering it in squares, which is why we get weird numbers. And that's why our units are squared. So if the side length was 6, it would be 6 times 6, which would be 36. And you can write feet to the second power, or you can literally write square feet. I knew a math teacher who forced his students to do that. I'm okay with either one. All right, if the side length is 8, then the calculation is 8 times 8, or 64 square feet. I'm going to use the other one, square feet. If the side length is 11, then your calculation is 11 times 11, or 121 square feet. If the side length is 4.2, 4.2 is fine. It doesn't have to be a whole number. We can multiply 4.2 times 4.2, and you should get 17.64. 17.64 square feet. And 10 and a half. So we can multiply 10 and a half times 10 and a half. That's good practice for the fractions we've been doing. Remember, you cannot multiply mixed numbers. So we have to make them improper fractions. 10 times 2 is 20, plus 1 is 21. So we get 21 over 2 times 21 over 2, which gives us 441 over 4. And when we turn that back into a mixed number, it's 110. I'll try the eraser, but it's time consuming. Nope, still eraser. Pen. 110 and 1/4 feet squared, or square feet. All right, the table now is in exponential form. We're on page 35. Please fill out this table in your book. So 2 squared is 2 times 2, which is 4. So this is product using the base as a factor twice, right? We call this expanded form. So powers, exponents represent repeated multiplication. So instead of writing it with the exponent, we can just write out the factors, right? These are factors because they're being multiplied. So 1 squared is 1 times 1, which gives us 1. 7 squared is 7 times 7, which gives us 49. 15 squared is 15 times 15, which gives us 225. All right. Reading math, I included this because it's important. So we read the expression 5 to the second power as 5 squared. Or we could say the square of 5. Or you could say 5 to the second power. These all mean the same thing. All right. They all mean 5 times 5. Find the value of the expression 9 squared, where 9 squared, if I write it in expanded form, is 9 times 9, so that's 81. Here it says the number 49 is the square of what number? So that's asking the question. If I had a number and I multiplied it times itself, I'm using n because I don't know what the number is. And when I use n again, I mean it's exactly the same number. So what number multiplied times itself would give me 49? And the way you do this is you guess, right? Guess a number. How about 5? Well, 5 times 5 is 25, so that's too small. So guess a bigger number. 6 times 6 would be 36. That's still too small. 7 times 7 is 49. So 7 would be the side length of a square that is 49 square feet in area. All right, so everything we can do in math, we can also undo. Undo and take the inverse. I'm going to use those interchangeably. Undo means take the inverse. Okay, when I grew up, we didn't really have undo because we didn't have computers. Shocking, isn't it? No computers. But inverse is the math word. It's a better word, inverse. But if you think undo, then maybe you'll be able to remember it. Okay, so if we add, we can subtract. If we multiply, we can undo the multiplication by dividing. If we square, we can undo squaring using square root. And think about this. If we cube, the undo is the cube root. We'll talk about that some more later. Okay, so the inverse of raising a quantity to a power is taking the square root. So here we have a square with a side length of 5. So that's the side length 5. And then we can use squaring to find the area, right? So 5 squared gives us 25. That's the area of the square. It would take 25 square inches of paper to cover this square. But if I have the area, 25, and I want to know what's the side length, we want to undo the squaring. So the inverse of squaring is square root, and that takes us back to 5. Okay, so now we are square rooting. And to find the square root, again, you basically guess, or you can memorize your squares. So you can start with 1 times 1, which is 1. Let's put them over here. So 1 times 1 is 1. 2 times 2 is 4. We're trying to get to 16 here. 3 times 3 is 9. 4 times 4 is 16. There we go. So the square root of 16 must be 4, because 4 multiplied by 4 gave us 16. Now we're looking for 81, so that's even bigger, so let's keep going. 5 times 5 is 25. 6 times 6 is 36. 7 times 7 is 49, still not there. 8 times 8 is 64. 9 times 9 is 81. There it is. So the square root of 81 is 9. Oh, 100. Let's keep going. 10 times 10 is 100. Well, that wasn't bad. So the square root of 100 is 10. Now, all of these numbers the product of two identical factors, these are all called perfect squares. Perfect squares. because you can take the square root of any of these numbers and get a nice whole number. You can take the square root of any number, but if you take a square root of a number that is not a perfect square, you won't get a nice whole number. And we'll talk about that some more later. Okay, so now let's fill in this. Let's fill in this table right here. Come on. So sometimes they're giving us the area, sometimes they're giving us the side length. If the area of the booth is 36, to get the side length, we're going to take the square root of 36, which is 6. If the side length of the booth is 8, to find the area, we have to multiply 8 times 8, or find 8 squared, which is 64. Here the side length is 9 feet, so we need 9 squared, which is 81, to get the area. Now we have the area is 121 square feet. Well, the side length is going to be the square root of 121, which is 11. And here the side length is 144. I'm sorry, here the area is 144. So to find the side length, we're going to take the square root of 144. We could keep going. I just told you that 11 times 11 is 121. 12 times 12 is 144. These are probably the most useful perfect squares to know. These right here from 1 to 12. So if you're the kind of person who memorizes things, memorize those. Okay, now we have x's involved. The whole reason you're learning that squaring and square rooting are inverses of each other is so that you can solve equations like this. Let's go back to 7th grade for a minute. When you had x plus 5 is equal to negative 2, you're trying to get x by itself to solve this equation. You're going to get rid of this 5. The inverse of adding is subtracting, so you subtracted 5 from both sides. You might not be surprised to think that I would add a negative 5 to both sides. So the plus plus the minus eliminate each other. They're inverses, and you get 0. Negative 2 plus negative 5 is negative 7. Okay, but sometimes you had a number multiplied times x. 3 times x equals 9. All right, well, if the number was multiplied times your variable, the inverse of multiplying is dividing. So you would divide both sides by 3, and you get x is equal to 3. But in every case, your goal was to get x by itself. You want the x all by itself. You don't want anything over there with x. It should be the only thing there. So let's look at this equation right here. X squared is equal to 64. My goal is to get x by itself without the squared. And we now know that the inverse of squaring is square root. So that's what you're going to do, and you're going to do it to both sides, just like you added a negative 5 to both sides, and you divided 3 on both sides. You're going to take the square root on both sides. Please show me that work on your quiz to get full credit. All right, so the square root of x squared is x, and the square root of 64 is 8, right? 8 times 8 is 64. We did that back here. 8 times 8 is 64. Okay. The thing is 8 is not your only answer. Remember, when we do problems like this, we can always plug the answer back in to see if it works. So I could plug in negative 7 for x. Instead of x plus 5, I have negative 7 plus 5. And I get the answer negative 2, so I know it works. I could plug in 3 for x. Instead of 3 times x, I'd have 3 times 3, and 3 times 3 is 9, so 3 works as an answer. If I plug x back in, 8 back in here for x, since x was squared, 8 will be squared, and you're probably saying, Mrs. Thomas, that totally works. And you're right, it does, but it's not the only answer that works. Do you see that negative 8 also works? Because when you square a negative number, it becomes positive, right? Any negative number squared becomes positive, which means negative 8 would also work. And since it works, it's an answer. Anytime you take the square root of both sides of an equation, you get two answers. When you take the square root of both sides of an equation, you will always get two answers. And it's super hard to remember this second one. So let's try it again. X squared is equal to 121. All right, so I know that the inverse of x of squaring is square rooting. And I'm going to take the square root of both sides. Do not just take the square root of 121. Okay, once I've taken the square root of both sides, I know that the square root of x squared is x, and the square root of 121 was 11, right? 11 times 11 is 121, so it's 11. But because it's a square root, I know it's also going to give me the answer negative 11. Two answers when you take the square root of a square. All right, let's look at the last one. X squared is equal to 1.44. It doesn't matter that there's a decimal there because it is being squared. I am going to take the square root of both sides. The inverse of squaring is the square root. So the square root of x squared is x. The square root of 1.44. Well, I know that, whoops, too far. Too far again. I know that 12 times 12 is 144. So I know the number 12 is going to be in here. But 12 times 12 is too big. I want just 1.44. Notice there are two decimal places. I wish this was easier. Come on. All right. There are two decimal places in the answer, which means there needs to be two decimal places in the problem, in the two numbers, the two factors that were being multiplied together. So if we give each of these factors a decimal place, right, then when we multiply them together, there would be two decimal places in our answer. So our answer is 1.2 and negative 1.2. Got it? The only time we're going to have two answers is if there is an x involved. The square root of 25 is just 5. It is not positive 5 or negative 5 because there's no x involved. There's no place to plug a negative 5 in and show you that it works, so it doesn't work. All right, last page. Page 37. We're just going to do these problems real quick. So 11 squared is 11 times 11, which is 121. 5.5 squared is going to be, let's do it down here. Oh, let's do it over here. So 5.5 squared is going to be 5.5 times 5.5, which gives you 30.25. Problem number 4. We can raise fractions to powers, no problem. 2/3 squared is just 2/3 times 2/3. Numerator times numerator, denominator times denominator. Number 5, the square root of 144. Maybe you've memorized that by now. It's 12. It's not 12 or negative 12. Do you see an x in this problem? No, so just one answer. And problem number 6, the square root of 64 is 8. Problem number 7 says, what would be the area of a square booth that has a side length of 9 feet? Side length. And do you see how this isn't squared? So in order to find the area, we're going to square that 9. And 9 times 9 gives us 81. And because it's feet, our units are square feet. All right, problem number 8. Problem number 8 has an x in it. They're asking you to solve for x. All right, so we are going to take the square root of both sides, because the inverse of raising to the second power or squaring is square root. And then the square root of x squared is going to be x. And the square root of 16 is 4. But negative 4 would also work if we plugged it in for x. So we got to write both answers down. Great. Wonderful job, everybody. It says desktop.